All right, welcome back everyone. In this one we're going to be talking about casting. Not a ton of coding, so feel free to kind of just sit back, relax, and enjoy. Casting is a technique that can be used to force a certain data type. For instance, a double can be truncated to an int using an integer cast. So I want you to think about this one for a moment. I'm going to plug it into IntelliJ in just a second. But 3.14, this is a double. We're trying to take this double and save it into an integer. Well, you can't do that. Simply put, a double takes up 8 bytes of data, and I'm trying to store it into something that can only hold 4 bytes. Well, the compiler just doesn't let it happen at all, but you could put this cast in front of it, and that is going to force it to work. As we actually see here in our print-off, we're going to get a 3 from that. And I'm actually going to run this in IntelliJ. I'm going to create a new project here. You don't have to do this. You can just watch if you would like. It's going to be short and sweet. Okay, I'm going to right click on my SRC, make a new Java class. I'm just calling it casting. It's whatever. We're just playing around. I just need a main method basically. Okay, if I try to just flat out save 3.14, you see IntelliJ underlines this with a red squiggly. This is a syntax error. This is a compile time issue. You can't save a double into an integer, and this is as far as I can get. But with a integer cast, what's going to happen is that we're going to force this to truncate. Notice IntelliJ is happy, right? We're going to get rid of this data. The part that can be an integer will be saved into X, and so whenever I try to print off X, we will see that happen. There we go, in just 3. Most importantly is that it gets rid of the syntax error. Okay. This is going to feel not kind of useful, but I'm going to show you some techniques that are useful. When you do casting, right, the cast is going to appear before the expression that you want to convert, and it tells the compiler you agree to information loss. Right? In that case, truncation was going to occur, and we're okay with that. Like the cast is saying, yeah, I know, let's make it happen. Here's a situation where casting becomes a little bit more useful. Right? Casting is useful in a number of applications. Here I have 5 divided by 4. Well, 5 is an integer, 4 is an integer. I have division between 2 integers. This is going to unwillingly truncate to just 1. However, you can come in here with a cast, and what it's going to do is it's going to treat the thing right behind it like a double. Right? In this case, what's right behind it is a 5. So we're going to say, let's treat this 5 like a double. Okay, now this is really 5.0 divided by 4, and that will stop the truncation from occurring. Let's play with that in IntelliJ real fast. Right? If I were to just flat out to do 5 divided by 4, why don't we comment these out? I'll run this again. Right? I got division between 2 integers. Truncation can occur. Okay, one thing that you can do is come in here with a cast. And what the cast is going to do is it's going to take the expression directly behind it, which is in this case a 5, and treat it like a double. We're saying to the compiler, let's treat this like a double. We understand all the repercussions that can happen from this, and in which case we don't get the integer truncation. Now, you may be thinking to yourself, well, Mr. Hubbard, couldn't we just, do a 5.0? Couldn't we just, numlock was not on. Couldn't we just do a 5.0? Yeah, right? And IntelliJ grays out the double here because that was essentially the same thing. So the question of why would I purposely do this is probably not, right? But what you will see is the possibility for this being like a multiple choice question, right? The AP CSA exam may use this cast here, and you have to kind of know what's going to happen. Now, where they could potentially trick you and where you'll see like a test question is what happens if I do this, right? what if I come in with some parentheses around this? Okay, well, this is a question of precedence. What has highest precedence? Does the cast have the highest precedence? Does the parentheses have a higher precedence? Where's division fit into this? Well, we can actually determine from what we previously had that division, our arithmetic operators, have a lower precedence than the cast. Why? Well, this cast happened first, and then the division happened. You can maybe argue that they're on the same level of precedence because we got like a left to right orientation, but I'm telling you that casting has a higher precedence than division, your arithmetic operators. Okay, however, if I come in here with parentheses, well, parentheses has the highest precedence, period, right? It should. That makes sense because that actually gives us the most control. We can add parentheses to force levels of precedence. Okay, now think about what happens if we do this first. Right, the parentheses is going to happen, which means we're going to forcefully do the division here inside of the parentheses. Right, that's division between two integers. That's going to truncate to just one. Then the cast gets applied, which is why we see a 1.0 in our output. It's saying take the 1 that we get from this operation, treat it like a double. So those are the types of test questions you will see involving this particular double cast and division. You got to be careful with precedence with those parentheses. Okay, this is arguably a little bit more useful. Now there's a reminder here, Math.round returns a long. Okay, for one thing, so Math.round is not overloaded, and here's the thing. Double has a larger number range than integer does, and so it is possible that whenever you take your double and round it, the number is still too large for an integer. That is why Math.round returns a long, right? This is always going to produce a long. However, I can't save a long into an integer. Let's demonstrate this. I'm going to create integer x, and it is going to be Math.round on 3.14. Okay, think about this for a moment. If we were to round 3.14 in the way that round works, it follows the normal math rounding rules. This should round down to 3, just 3. Okay, but if you scroll over this error, right, it's red, IntelliJ's not happy. It tells us that this is returning a long. It has to, again, because the number range for double is larger than that of an integer, so it's possible that whenever you round whatever number here, whatever double here, that it's too large to fit into an integer, so it's producing a long data type. Okay, now that being said, a good portion of the numbers that you're rounding are going to be in the number range of an integer, so an integer cast can be used to say, let's treat this long like an integer. I am fairly certain that what we're going to get back here is going to be able to fit into an integer. So the cast says, okay, let's do that. And you'll see if I print this off, we're going to get just a simple 3 from that. And we'll see that this follows normal rounding rules. If I go to 3.49, still not quite there. That's going to round down to a 3. The moment that I go to 3.5, we're going to round up from there, and you'll see that we get a 4. Okay. This is where it starts to get real useful. All right, let's take a moment to appreciate this. I have this double pi, and it has the value of 3.14. On the next line, I take pi, and I cast it. Right, that's going to be 3. And then lastly, I come in here with another double. I take my original value, I subtract out the cast, and mathematically what I have done here is I have separated the whole number portion from the fractional part. This is a pretty cool technique, right? Using casting, I can separate the whole number portion from the fractional part. So if I have our double, why don't we bring in scanner for this? So we can play with some numbers here. I'm going to not do that. Instead, I'm going to skip to my second step, which is creating my scanner. I can hover over this, hit Alt-Enter, and it'll import scanner for me. Alright, so I'm going to create scanner that reads from the keyboard. Why don't we say enter a double? A double. I'm going to get rid of the ln here so that the user's input appears right next to my prompt. Let's capture that. I don't know, num. Alright, so I'm just breaking in scanner so we can get a double from the user. Now, what I'm really going to show off here is the casting technique, where we can basically get the integer portion. Hold on, I'll just say whole. We're going to take our double. Right? Normally I can't do this. Right? I'm trying to save a double into an integer, but I can cast it, which is going to force truncation. So this is going to give me the whole number portion. Whole number portion. I can then, after I've separated out the whole number portion, get the fractional part. Why don't we just call that fract? And I'm going to take my original number and I subtract out the whole number. Well, the only thing that's left after I subtract out the whole number is the fractional part. So why don't we see that? I'm going to print off maybe my whole number. And then I'm going to print off my fractional part. Enter a double. If I do 3.14, ignore this. So see, we have our whole number part, and then we see our fractional part. I'll talk about this for a moment. This is due to binary, effectively. So in the same way that we can't represent fractional numbers exactly in our number system, what do I mean? Okay, I just comment it in here, right? The number, if I do 1 divided by 3, don't think about Java for a moment. In the real world, 1 divided by 3, right? If I actually do that math, we end up with 0.33333 repeating. I cannot represent this number exactly in the decimal system. Okay, the same thing occurs in binary, just more frequently. And so this is a side effect of all number systems, right? And realities are that this number is stored in binary in the actual computer. And so this math can't be done exactly. Really, this number 0.14 just can't be, it's just not exact. The technique is still true though. So let's do a different double. Similar thing here. Okay. So I find this useful as a way to separate these things out. And yeah, this is going to be close. And practice, I mean, the precision on this is actually like really good. Think back to our 3.14 that we just had. Yeah, I get this, but look how many zeros deep this is. Right? This is actually really precise, despite the fact that it's not exact. This is one that you will see on the AP exam, a technique that they like to use. Right? We take some double, and we can use this expression to create our own rounding technique. Okay, again, Math.round exists, and I showed you how you can cast that and get an integer from it. But the AP exam will sometimes do this to kind of do a round, because as it turns out, Math.round is not actually in the subset. I'm going to leave scanner in. So we're getting a double. Right? And I'm going to use this technique where I take my double, we're going to add 0.5, Then we're going to cast that and see how it rounds. Okay, so I've already got my double. I just want to round it. And the way we're going to do that is that we take that number, we add 0.5, and then we'll use parentheses to make sure that this expression happens first, and then that gets casted so that we can save it into our integer. I want to see the end result here. So let's print off round. And I'll test this with several different numbers using our double. So enter a double. Okay. What about 5.49? Think about a moment. What should that round to? Should round down to 5. Okay. What happens here is that we have this 5.49 that comes in. We're going to add 0.5 to it. All right. Think about what that is. It's the moment that you do that, it is what? 5.99? Okay. Then this cast occurs. Right? Well, what does casting do? It effectively will truncate the double to just an integer. And that's what ends up getting saved into our round value. Now, if I were to run this with a different number, what happens the moment that we do something a little bit larger, right? What if I do 5.51? Well, that's going to round to 6, and that makes sense. What happens is, again, the num comes in, 5.51. 5.51. We're going to add 0.5 to that. That's going to give us, what, 6.01. Then the cast occurs. That's going to truncate it. It's going to get rid of this fractional part, and so we're left with 6. That's what's getting saved into our round value and ultimately displayed. So this is a pretty cool technique to kind of do your own rounding. Something to keep in mind is that casting is useful, it's not magical. Cast between incompatible data types will result in a syntax error. I can't take a string and then just magically cast it to a double. Here I'm trying to take a double and treat it like a string. That doesn't work. Now, that being said, one easy way that I may have taught you to basically convert a string into a double is to basically do concatenation, right? So I want, if I just try to save 3.14 into this, it doesn't work. If I try to cast it like a string, that doesn't work. What you can do is use concatenation. I'm going to take 3.14 and I'm going to concatenate it with a empty string. Here I have double quotes. It's technically a string. It's a string literal with a length of 0. And anytime that you concatenate anything with a string, Java behind the scenes is going to do the conversion. Right? In this case, I want to take 3.14 and effectively add nothing to it. So this isn't going to change my 3.14 value, but it is going to concatenate it, force it to be a string. And you see, I mean, IntelliJ is happy. We've turned this 3.14 from a double into a string by forcing it through concatenation. So that's an interesting technique. What's a little bit harder is to take a string and turn it into a double. What do I mean? Well, if I try to save 3.14 into this, that's not going to work. And we don't have a similar technique, except we kind of do. I'm going to show you this. I never show this to my students. But we could do double, parse double. I want you to think about this for a moment. We're going to see this very soon. This is double with a capital D. The capital letter here, notice that it's not this text. What this is this is a class. Notice I did not create an object. So what can you tell me about parse double? Well, IntelliJ is trying to tell us, it's italicized here. This is a static method coming out of a class called double. And what it does is it takes whatever is here, a string, right, which they called S, a string, and it's going to try to turn it into a double number that gets returned. Let's print this off. This is definitely outside the subset. But I showed you how to turn a string into, I'm sorry, a double into a string. Well, what about turning a string into a double? For that, you would need something called parse double. Don't worry too much about this, not in the subset. Really, this isn't either. These are just techniques that I'm showing you. But that is the end of casting.